Hello there, and welcome to Calm Science. Settle into a position that feels effortless. Allow your body to grow heavy, to feel supported by the surface beneath you. Your only task tonight is to rest. Let the breath slow on its own, finding a quiet and easy rhythm. There is nothing to solve, nothing to hold on to. The mind can idle, free to drift at any moment without losing the thread of our journey. Tonight we are not climbing mountains or exploring distant stars. Instead, we are following the gentle, patient path of water. We are drifting toward the places where rivers meet the sea, the quiet landscapes known as deltas. We will explore how these lands are born from water and earth, shaped by currents, tides, and time itself. There is no hurry. You can fade in and out. The story of the delta is one of slow creation, and its pace is perfect for sleep. A river delta is a landform created from the deposition of sediment. This sediment is carried by a river as its current leaves its mouth and enters slower moving or standing water. This might be an ocean, a sea, a lake, or even another river. As the river's flow slows down, it loses the energy needed to carry its load of sand, silt, and clay. These particles, carried for hundreds or thousands of kilometers, finally come to rest. Over long periods, this accumulation builds up, layer by layer, creating new land where there was once only water. It is a slow and patient process of construction, a quiet collaboration between river and sea. In this way, the river does not just end but transforms, giving its earth back to the world. Let that idea rest for a moment before we move on. The name delta comes from the fourth letter of the Greek alphabet. It was the ancient Greek historian Herodotus who first used the term. When he observed the fan-shaped mouth of the Nile River, he saw its resemblance to the triangular shape of the capital letter delta. While many deltas are indeed triangular, the term now applies to any river mouth landform built by sediment, regardless of its specific shape. Some are shaped like a bird's foot, others like a gentle curve, and some are held within the straight lines of an estuary. The shape is simply a response to the quiet forces at play, the river's strength and the ocean's influence. As you rest, you can imagine these simple, powerful shapes drawn slowly upon the surface of the water. Nothing urgent here, only a slow and steady pattern. River deltas are most common in areas with a large drainage basin. A drainage basin, or watershed, is the entire area of land, where water from rain or melting snow collects and drains into a single river. The larger the basin, the more water the river gathers, and the more sediment it can carry. Rivers like the Mississippi in North America, or the Amazon in South America, have immense drainage basins that span entire continents. They collect soil and rock particles from vast landscapes, carrying this material on a long, unhurried journey. This abundance of sediment is the essential ingredient for building a large and persistent delta. Without a steady supply, the land-making process would slow or even reverse. You can breathe a little deeper and allow the thought to drift. The formation of a delta begins underwater. As the river flows into a larger body of water, the heaviest particles, like sand and gravel, are the first to drop out of suspension. They settle near the river mouth, forming an underwater deposit. The finer particles, like silt and clay, are carried a little farther out before they too settle to the bottom. Over time, these submerged deposits build up, creating a gentle slope known as the delta front. Eventually, this underwater platform grows so high that it reaches the surface of the water, forming the first visible land. This new land is soft and low-lying, a quiet foothold for the delta's expansion. From a distance, it appears as a simple, gradual emergence of earth from water. Hold the shape of that thought lightly and return to ease. Not all rivers form deltas. Some rivers empty into oceans with strong tides or powerful waves. In these high-energy environments, the ocean currents are strong enough to carry away the sediment as quickly as the river delivers it. The constant motion of the water prevents the particles from settling and accumulating near the river mouth. Instead of building land outward, the sediment is dispersed along the coastline or carried out to the deep sea. The river's journey simply ends, its contents scattered by the more powerful forces of the ocean. The conditions must be just right, calm enough for the river's gentle offering of earth to be accepted and to find a place of rest. Let the body grow heavier as the mind stays simple. One of the most recognizable types of deltas is the arcuate delta. This is a fan-shaped delta, much like the original triangular shape that gave the landform its name. Arcuate deltas, like that of the Nile River, typically form where a river with a heavy sediment load meets a sea with effective, but not overwhelming, wave action. The waves and currents gently spread the deposited sediment along the coast, rounding the delta's outer edge into a smooth, curved shape. The river's flow splits into many smaller channels, called distributaries, which spread out across the fan like the veins of a leaf. Elsewhere in this picture, the arc itself is a line of balance between the river pushing out and the sea pushing back. Let that settle like dust on a quiet floor. As a delta grows, the river's main channel can become inefficient. The path to the sea becomes longer and the slope of the riverbed gentler, which slows the water down. At some point, often during a large flood, the river may find a shorter, steeper path to the sea. It breaks through its natural banks, or levees, and carves a new channel. This process is called avulsion, or channel switching. The old channel is gradually abandoned, and the focus of sediment deposition shifts to the new river mouth. This is how a delta grows over wide areas, not just at one point. The river builds a section, or lobe, of the delta for a few hundred or thousand years, and then switches to build another one elsewhere. Return to the easy rhythm of your breath. The Mississippi River Delta is a classic example of a river-dominated delta. Its shape is often described as a bird's foot, with long projecting fingers of land stretching out into the Gulf of Mexico. This unique shape forms because the river's flow is much stronger than the influence of waves or tides in the Gulf. The river carries a massive amount of fine-grained sediment far out into the calm water. It builds its own channels forward, extending them like tendrils. Each one of these channels, or distributaries, deposits sediment at its end, creating the long, narrow lobes that resemble the toes of a bird. In this quiet corner of the world, the river is the primary architect, drawing its own shape with silt and clay. Let the thought soften at the edges and fade. Deltaic soils are exceptionally fertile. The sediment that rivers deposit is rich in nutrients and organic matter collected from across the entire drainage basin. This regular replenishment of soil makes deltas some of the most productive agricultural regions on Earth. For thousands of years, civilizations have thrived in places like the Nile Delta and the Mekong Delta, relying on the annual floods to bring new, fertile silt. These lands can be cultivated year after year without losing their richness. The soil is fine-grained, holds moisture well, and provides a perfect medium for crops like rice, cotton, and wheat. With simple patience, the river provides not just land, but also the nourishment that sustains life upon it. Rest in the steady comfort of this moment. The Ganges-Brahmaputra Delta is the largest delta in the world. Located in Bangladesh and India, it empties into the Bay of Bengal. This immense delta is formed by the confluence of several major rivers, including the Ganges, Brahmaputra, and Meghna rivers. It covers an area of about 100,000 square kilometers. The landscape is a complex and ever-changing network of waterways, mudflats, and forested islands. Because it is so low-lying and vast, it is particularly sensitive to the rhythm of the monsoon rains and the level of the sea. It is a land that is not quite solid, a place where the boundary between water and earth is always shifting in a slow, silent dance. Set the idea down and feel the weight release. Deltas are constantly compacting and sinking, a process known as subsidence. The newly deposited sediments are often loose, with a lot of water trapped between the particles. As more and more layers of sediment build up on top, the weight presses down on the layers below. This pressure squeezes the water out and compacts the sediment, causing the land to slowly sink. In a natural, healthy delta, the rate of subsidence is usually balanced by the rate of new sediment deposition. The river brings enough new material to keep the delta's surface at or above sea level. This is a quiet vertical balance, a slow settling that is constantly being countered by new growth. Let your shoulders drop and the jaw unclench. The Okavango Delta in Botswana is a rare and beautiful example of an inland delta. Unlike most deltas that empty into an ocean, the Okavango River flows into the Kalahari Desert and spreads out over a vast flat plain. The water never reaches the sea. Instead, it creates a massive wetland oasis, a network of channels, lagoons, and islands in the middle of an arid landscape. Most of the water is eventually lost to evaporation into the dry desert air or transpiration from the lush vegetation. This unique environment supports an incredible diversity of wildlife. It is a delta that exists not at the end of a continent, but in its heart, a river that finds its end not in an ocean, but in the sky. Feel the calm gather around you again. Beneath the surface of a delta lies a detailed history of its formation. Geologists can take core samples, long cylinders of sediment drilled from the ground, to read this history. The layers of sand, silt, and clay are like the pages of a book. A thick layer of sand might indicate a time of strong river flow, perhaps from a major flood. A dark layer rich in organic material could mark the location of an ancient marsh. By studying these sequences, scientists can reconstruct how the delta grew, where its channels used to be, and how the environment has changed over thousands of years. With unhurried steps, they can trace the slow and patient story written in the earth. Settle back into the soft pace of night. Wave-dominated deltas have a much smoother and more regular shoreline. In these systems, the ocean's wave energy is the most powerful force shaping the landform. As the river deposits sediment at its mouth, the waves immediately rework it, spreading it evenly along the coast. This action prevents the formation of long, projecting distributaries like those of a bird's foot delta. Instead, it creates a straight or gently curved coastline with fewer channels. The São Francisco River in Brazil is a good example. Its delta is characterized by a series of beach ridges parallel to the coast, built up by the constant sorting action of the waves. In the gentle background, the ocean acts like a steady hand, smoothing the edges of the land. Allow the mind to idle in gentle space. The top part of a delta, the visible land surface, is called the delta plain. This plain can be divided into two parts. The upper delta plain is farther inland and is mostly unaffected by tides. It is the oldest and most stable part of the delta, often covered in forests or used for agriculture. The lower delta plain is closer to the sea and is regularly influenced by tides. This area is a mosaic of active distributary channels, marshes, mudflats, and shallow bays. It is the most dynamic part of the delta, where land is actively being built and reshaped by the interplay of river and sea. Through a soft lens, you can see these two regions as different stages of the same quiet process of creation. Let the body be held by what supports you. Vegetation plays a crucial role in building and stabilizing deltas. As soon as new land emerges, plants like reeds, grasses, and mangroves begin to take root. Their root systems bind the loose sediment together, making it more resistant to erosion from wind and water. The stems and leaves of the plants also slow down the flow of water, both from the river and from tides. This encourages even more sediment to drop out of suspension and accumulate. In this way, the plants act as ecosystem engineers, actively helping to build the land they live on. It is a gentle partnership where life helps create its own foundation, one root at a time. Allow the day to fall away now. Distributaries are the smaller channels that branch off from a main river as it flows across a delta. The word distributary is the opposite of a tributary, which is a stream that flows into a larger river. As the river approaches the sea, its slope decreases and it begins to deposit sediment within its own channel. These deposits can form bars that split the flow, creating a network of smaller streams that spread out across the delta plain. This branching allows the river to distribute its water and sediment over a wide area, which is essential for the delta's growth. Each small channel carries a portion of the river's load, contributing to the quiet work of land building. Rest in the quiet that follows. A tide-dominated delta looks very different from other types. It typically forms in an estuary or a bay where the tidal range is large. The strong back-and-forth motion of the tides becomes the main force for distributing sediment. Instead of a fan or a bird's foot shape, these deltas are characterized by a series of long linear islands or sandbars that are aligned parallel to the direction of the tidal flow. The Ganges-Brahmaputra is a prime example of a delta heavily influenced by tides. Its channels are deep and wide to accommodate the massive volume of water moving in and out with each tide cycle. The land itself seems to flow with the rhythm of the water. Let your breathing find a slower pace. Deltas are incredibly important ecosystems, often referred to as coastal wetlands. They provide a unique habitat where fresh water from the river mixes with salt water from the sea. This creates a range of environments, from freshwater marshes to brackish estuaries and salt marshes. This variety of conditions supports an immense diversity of life. They are critical nursery grounds for many species of fish and shellfish, which lay their eggs in the sheltered, nutrient-rich waters. They are also vital stopover points for migratory birds on their long journeys. In this quiet corner, life finds a gentle refuge, a place of abundance and safety. Feel the simple ease of being here. The amount of sediment a river carries is called its sediment load. This load consists of particles of all sizes, from large pebbles down to microscopic clay. The larger particles are usually rolled or bounced along the riverbed. The smaller particles are held in suspension by the turbulence of the water, giving the river a cloudy or muddy appearance. A river's ability to transport sediment depends on its velocity. Faster flowing water can carry more and larger particles. As the river slows upon reaching a delta, this capacity diminishes and the sediment begins its final descent. As the night settles, you can picture this slow release, a gentle letting go of a long-held burden. Hold only the calm and let the rest drift. Delta lobes are the distinct bulges of land that form at the mouths of major distributaries. A large delta like the Mississippi is not one single landform, but a composite of many overlapping lobes built at different times. As we've learned, a river will build one lobe for several centuries and then undergo avulsion, switching its course to a new location. The old, abandoned lobe then begins to sink and erode, deprived of its supply of fresh sediment. The new, active lobe starts to grow outwards. This cycle of lobe switching and abandonment is a fundamental process in the life of many deltas, a repeating pattern of focused growth followed by quiet decay and renewal. In this calm rhythm, the delta breathes, expanding and contracting over vast timescales. The land is quiet, and so is the mind. The Lena River in Siberia forms a massive delta as it empties into the Arctic Ocean. For about 7 months of the year, this delta is frozen solid. The river ice and the sea ice merge, and the landscape becomes a vast, silent plain of white. When spring arrives, the thaw begins. The huge volume of meltwater and the breakup of river ice cause a massive, but brief, flood that reworks the channels and deposits a fresh layer of sediment. This Arctic delta is a place of extremes, defined by a long period of stillness followed by a short, powerful burst of activity. It is a delta that grows not continuously, but in a single annual pulse of immense energy. The water flows onward without ever rushing. Natural levees are raised, banks of earth that form along the edges of a river channel. During a flood, when the river overflows its banks, the water spreads out and slows down. The coarsest sediment drops out first, right next to the channel, while finer materials are carried farther away. Over time, repeated floods build up these ridges of slightly higher ground. On a delta, these natural levees can be the most stable and driest land, making them preferred locations for vegetation and, in many cases, human settlement. They form gentle, linear features that trace the paths of active and abandoned channels across the low-lying delta plain. With steady breath, the river builds its own containers. Let that idea rest for a moment before we move on. The sediment delivered by a river to the ocean often forms a visible plume. This is an area of discolored water extending from the river mouth out to sea. The color comes from the fine-grained silt and clay suspended in the fresh water. Because fresh water is less dense than salt water, the river's flow often spreads out over the surface of the ocean in a distinct layer. From space, these plumes are beautiful, swirling patterns of light brown or green against the deep blue of the sea. They show the path of the river's water even after it has left the confines of its channel, a visible whisper of the land dissolving into the ocean. As the pattern repeats, these plumes nourish offshore ecosystems with nutrients. Nothing urgent here, only a slow and steady pattern. An inland delta, like the Okavango, can also be formed where a river flows into a large, flat, arid region. The Peace Athabasca Delta in Canada is another such example, one of the largest freshwater deltas in the world. It is located where the Peace and Athabasca rivers flow into Lake Athabasca. This vast complex of wetlands, lakes, and rivers provides an incredibly important habitat, particularly for waterfowl. Unlike the Okavango, much of its water does eventually find an outlet to the Arctic Ocean, but only after spreading out and nourishing this immense northern oasis. Such inland systems remind us that the process of delta formation is about the loss of water's energy, a phenomenon that can happen far from any ocean shore. You can breathe a little deeper and allow the thought to drift. Cuspate deltas are tooth-shaped or pointed landforms that protrude from a coastline. They form where a river discharges into a sea with strong waves that approach the coast from two opposing directions. The sediment from the river mouth is pushed back towards the shore and shaped into two curved beaches, one on each side, that meet at a sharp point. The Tiber River in Italy is a classic example of a river that has built a cuspate delta. The shape is a perfect equilibrium, a symmetry created by the river's outward push being met by the wave's regular angled push from either side. It is a landform held in a delicate, pointed balance. Hold the shape of that thought lightly and return to ease. Many of the world's most ancient civilizations arose on deltas. The fertile soils and abundant water of the Nile Delta sustained ancient Egyptian society for millennia. In Mesopotamia, the land between the Tigris and Euphrates rivers, the early floods of their shared delta created the conditions for the birth of agriculture in the first cities. These landscapes were not just easy places to live. They were engines of creation. The reliability of the floods allowed for predictable harvests, food surpluses, and the development of complex societies. Humans learned to live in harmony with the river's rhythm, a slow pulse of flooding and farming that shaped culture itself. Let the body grow heavier as the mind stays simple. Mangrove forests are a key feature of many tropical and subtropical deltas. Mangroves are trees and shrubs that are specially adapted to live in the salty, waterlogged soils of the lower delta plain. They have complex root systems that anchor them in the soft mud and help them breathe in an oxygen-poor environment. These dense forests are incredibly important. They protect the coastline from erosion by dissipating wave energy. They trap huge amounts of sediment, helping to build land. And they provide a unique and vital habitat for countless species, from crabs and shrimp to fish and birds. Following the water's lead, mangroves create a quiet, tangled frontier between the land and the sea. Let that settle like dust on a quiet floor. Human activities can have a profound impact on deltas. The construction of dams and reservoirs far upstream can trap a significant portion of a river's sediment load. This starves the delta of the material it needs to counteract natural subsidence and erosion. The Nile Delta, for example, has seen significant erosion since the construction of the Aswan High Dam, which captures nearly all of the river's sediment. Without the annual replenishment of silt, the delta is slowly being worn away by the waves of the Mediterranean Sea. This gentle balance, maintained for thousands of years, can be disrupted by changes made hundreds of kilometers away. Return to the easy rhythm of your breath. The process of a delta building outwards into the sea is called progradation. This is the healthy, natural state for most deltas, where the input of sediment from the river is greater than the amount of land lost to erosion and subsidence. The shoreline gradually advances year by year as new layers of sand and silt are laid down. This forward movement is often not continuous, but happens in pulses related to major floods that deliver large amounts of sediment. It is the constructive phase of a delta's life, a slow and steady march of the land into the water. Over time, this quiet advance can create vast new territories. Let the thoughts soften at the edges and fade. Retrogradation is the opposite process, where a delta's shoreline retreats. This happens when the forces of erosion and subsidence are stronger than the supply of new sediment. The waves and currents of the sea begin to win the battle, washing away the land faster than the river can replace it. This can be a natural part of a delta's cycle, especially in an abandoned lobe. However, it can also be accelerated by human factors like dam construction or by rising sea levels. When a delta is in a state of retrogradation, it is slowly shrinking, its land being reclaimed by the water. Rest in the steady comfort of this moment. The Mekong Delta in Southeast Asia is a vast and populous region, often called Vietnam's Rice Bowl. Formed by the Mekong River, it is a low-lying, intricate maze of waterways and fertile fields. The delta's rhythm is dictated by the monsoon. During the wet season, the river swells, flooding the plains and depositing a new layer of rich silt. Farmers have adapted their lives to this cycle, growing rice and paddies that are submerged for part of the year. The delta is a place where human life and the river's life are deeply intertwined. The water provides transport, sustenance, and the very ground beneath their feet, a gentle but powerful presence in every aspect of life. Set the idea down and feel the weight release. The composition of delta sediments can vary greatly. Some rivers flowing through rocky, mountainous regions might carry coarse sand and gravel. Others, draining vast, flat plains with fine soils, will carry mostly silt and clay. This difference in sediment type affects the shape and stability of the delta. Sandy deltas tend to have steeper slopes and are more permeable to water. Deltas made of fine clay and silt, like the Mississippi, are flatter, more compact, and less permeable. This affects everything from the types of plants that can grow to the way the groundwater behaves. Under quiet skies, the character of the river's source is imprinted on the land it creates at its end. Let your shoulders drop and the jaw unclench. The Zambezi Delta in Mozambique is a stunning example of a delta ecosystem. It is a vast mosaic of grasslands, savannas, mangrove forests, and riverine wetlands. This diversity of habitats supports a rich array of wildlife, including large populations of water birds, For centuries, the delta's ecosystem was shaped by the natural flood pulse of the Zambezi River. However, the construction of upstream dams has altered this flow, reducing the floods that once nourished the floodplains. Efforts are now underway to manage the dams in a way that mimics the natural flood cycle, a careful attempt to restore the gentle rhythm that the ecosystem depends upon for its health and vitality. Feel the calm gather around you again. The slope of a delta, both above and below the water, is typically very gentle. The delta plane itself may have a slope that is almost imperceptible to the eye, dropping only a few centimeters for every kilometer. The underwater portion, the delta front, also slopes away very gradually. This low gradient is a direct result of the deposition process. The fine sediments settle out to form broad, flat layers. It is this flatness that makes deltas so susceptible to flooding, both from the river and from the sea. A small increase in water level can cover a vast area of land. From a distance, the delta appears almost perfectly level, a calm interface between water and sky. Settle back into the soft pace of night. Deltas are not permanent features on a geological timescale. They are ephemeral, existing in a delicate balance between creation and destruction. Over thousands of years, changes in sea level, climate, or tectonic activity can cause a delta to grow, shrink, or disappear entirely. During the last ice age, when sea levels were much lower, rivers formed deltas far out on the exposed continental shelf. As the ice melted and the seas rose, these ancient deltas were submerged. The deltas we see today are relatively young features, most having formed in the last 7,000 to 8,000 years, a period of relatively stable sea levels. Allow the mind to idle in gentle space. Crevasse splays are features that form when a river breaks through its natural levee during a flood. Water and sediment burst through the breach and spread out into the adjacent floodplain, which is typically a marsh or a bay. The flow of water is similar to a miniature delta forming, depositing a fan-shaped wedge of sediment. These events are important for delivering sediment and nutrients to the wetlands and back bay areas that are distant from the main channel. They are a key part of how a delta builds land, not just at its mouth, but also across its entire plain. Each splay is a small, sudden act of creation, a patch of new earth laid down in a flood. Let the body be held by what supports you. The Rhone Delta in the south of France is famous for its unique landscape, the Camargue. This region is a large delta plain with extensive saltwater lagoons, marshes, and agricultural lands. It is renowned for its wild white horses, black bulls, and vibrant flocks of flamingos that feed in the shallow, brackish waters. The delta is shaped by the powerful Rhone River and the waves of the Mediterranean Sea. It is a carefully managed landscape where humans have worked for centuries to control the water and preserve both the agricultural and natural areas. In this gentle flow, a balance is struck between wildness and cultivation, creating a place of rare and quiet beauty. Allow the day to fall away now. Salt marshes are a common habitat in the deltas of temperate regions. These are coastal wetlands that are flooded and drained by the salt water brought in by the tides. They are dominated by salt-tolerant grasses and other low-growing plants. These marshes are incredibly productive ecosystems. They protect shorelines from erosion, filter pollutants from the water, and provide essential habitat for fish, birds, and other wildlife. The slow decay of marsh plants creates a thick layer of peat, a carbon-rich soil that stores vast amounts of carbon, helping to regulate the climate. In this way, these soft, grassy plains perform quiet work of global importance. Rest in the quiet that follows. The concept of a deltaic cycle describes the life of a single delta lobe. It begins with the avulsion of the river, which establishes a new course. In the early stage, the new lobe builds outward rapidly, a process called progradation. As the lobe extends farther into the sea, its slope flattens and the channel becomes less efficient, Eventually, the river will abandon this path for a new, steeper one, and a new cycle will begin elsewhere. The abandoned lobe, now starved of sediment, enters a transgressive phase. It begins to subside and erode, and the shoreline retreats. This long, slow rhythm of growth, abandonment, and decay is what builds a complex, multi-lobe delta over millennia. Let your breathing find a slower pace. The Volga Delta is the largest river delta in Europe. It forms where the Volga River, Europe's longest river, flows into the Caspian Sea. The Caspian Sea is the world's largest inland body of water, and its level has fluctuated significantly throughout history. This has had a profound effect on the delta's growth. When the sea level falls, the delta builds outward quickly. When the sea level rises, the delta's growth slows or reverses. The delta's shape and size are therefore a direct reflection of the Caspian Sea's long-term behavior. It is a landscape that is intimately linked to the gentle rise and fall of its destination, breathing in and out with the sea's slow rhythm. Feel the simple ease of being here. The sediment deposits in a delta are naturally sorted by the water. The heaviest and coarsest particles, like sand, are deposited first in the areas with the fastest flowing water, such as the main channels and the river mouth. The finer particles, like silt and clay, are carried longer and settle out in the calmer waters of the floodplains, marshes, and the farther offshore areas. This predictable distribution of sediment sizes is called sorting. It creates a subtle but organized structure within the delta, with sands forming the skeleton of the channels and levees, and clays and silts making up the soft flesh of the wetlands in between. With the same easy pace, the water organizes the land it builds. Hold only the calm, and let the rest drift. The groundwater systems within a delta are complex. The layers of sand, silt, and clay create a layered aquifer system. The sandy layers are permeable and can hold and transmit water easily, forming freshwater aquifers. The clay layers are much less permeable and act as confining layers, separating the different sandy aquifers. In many deltas, the freshwater sits on top of denser saltwater that is intruded from the sea. Overpumping of the freshwater can cause this saltwater to rise, a problem known as saltwater intrusion. Beneath the surface, there is a hidden world of water flowing through layers of earth with the same quiet patience as the river above. The land is quiet, and so is the mind. The Yukon Delta in Alaska is one of the largest and most pristine deltas in the world. It is formed by the Yukon and Kuskokwim rivers flowing into the Bering Sea. The delta is a vast expanse of tundra, dotted with countless small lakes and ponds, and crisscrossed by a dizzying network of river channels. It is a vital breeding ground for hundreds of thousands of geese, swans, and other water birds that migrate there each summer. The landscape is underlain by permafrost, permanently frozen ground, which prevents water from draining and contributes to the abundance of surface water. It is a wild and remote place, shaped by ice and water in a slow Arctic rhythm. The water flows onward without ever rushing. River deltas are on the front lines of climate change and sea level rise. Because they are so low-lying, even a small increase in global sea levels can lead to the permanent inundation of large areas of land. This effect is compounded in deltas that are also sinking due to subsidence. The combination of rising seas and sinking land, a process known as relative sea level rise, poses a significant threat to the ecosystems and the millions of people who live on deltas worldwide. The quiet balance that allowed these lands to form is now being altered, and their future is uncertain. In quieter hours, a slow and silent change is taking place at the edge of the continents. Let that idea rest for a moment before we move on. Deltas are often classified based on the dominant processes that shape them. The Galloway classification system, a widely used model, places deltas on a triangle. The three corners of the triangle represent river dominance, wave dominance, and tide dominance. A delta's position within this triangle depends on the relative strength of these three forces. The Mississippi is a classic river-dominated delta. The Sao Francisco is wave-dominated, and the Ganges-Brahmaputra is tide-dominated. Many deltas, however, fall somewhere in between, shaped by a mixture of these forces. This simple triangle helps us understand the quiet conversation between river, wave, and tide that creates such a variety of forms. Nothing urgent here, only a slow and steady pattern. The top layer of a delta sediment, known as the topset beds, are the deposits of the delta plain. These are laid down by the distributary channels and floodwaters. They consist of a mixture of sand, silt, and clay arranged in patterns of channels, levees, and floodplains. Beneath these lie the foreset beds. These are the dipping layers of the delta front, the sediment deposited on the submerged advancing slope of the delta. And at the very bottom are the bottom set beds, the finest particles of silt and clay that settle out in the deeper, calmer water ahead of the delta. This vertical sequence, from bottom set to top set, represents the delta's gradual advance into the sea. You can breathe a little deeper and allow the thought to drift. The Irrawaddy Delta in Myanmar is another vast, low-lying, and fertile region. For centuries, it has been the country's primary rice-producing area. The delta is a classic arcuate, or fan-shaped delta, though its shoreline is heavily influenced by tidal processes. It is crisscrossed by a complex network of distributaries and tidal creeks. The lower parts of the delta are fringed with extensive mangrove forests, which are vital for protecting the coast from storms. Like many of Asia's great deltas, it is densely populated and intensely cultivated, a landscape where the lives of millions of people are shaped by the gentle but powerful rhythms of the water. Hold the shape of that thought lightly and return to ease. Peat is a type of soil that forms in the waterlogged, oxygen-poor conditions of deltaic wetlands and marshes. It is composed of partially decayed plant material. The lack of oxygen slows down decomposition, allowing thick layers of organic matter to accumulate over thousands of years. This peat can store enormous amounts of carbon, locking it away from the atmosphere. In some deltas, these peat layers can be many meters thick. When deltas are drained for agriculture, this peat is exposed to the air, and it begins to decompose rapidly, releasing carbon dioxide and causing the land surface to sink dramatically. The slow work of millennia can be undone in just a few decades. Let the body grow heavier as the mind stays simple. Many deltas have what is called a delta front, which is the seaward sloping edge of the delta. This is an area of active deposition where the river's distributary channels deliver sediment. This zone is constantly changing, with channels shifting, sandbars building up and eroding, and new land emerging. It's the most dynamic part of the entire system, where the direct contest between the river's outflow and the ocean's energy takes place. The slope is usually very gentle, and the sediment here tends to be coarser than that found further offshore. It represents the active, growing edge of the land. Over time, this front slowly advances, pushing the land further into the sea. Let that settle like dust on a quiet floor. The process of building a delta is not a smooth, continuous one. It is often characterized by periods of rapid growth during floods, followed by long periods of relative calm. A single large flood can carry more sediment than the river transports in several years of normal flow. During these events, the river has immense power, scouring its channel, breaking through levees, and depositing vast sheets of sand and silt across the delta plain and at the river mouth. These floods are the primary construction events in a delta's life. The time in between is for settling, for compaction, and for the slow colonization by plants. As you rest, the delta waits patiently for the next pulse of new earth. Return to the easy rhythm of your breath. The Niger Delta in Nigeria is one of the world's largest deltas and a major oil-producing region. It is another example of an arcuate or fan-shaped delta. Its growth is influenced by a combination of strong river flow and powerful wave action from the Atlantic Ocean. The outer edge of the delta is smoothed by waves into a series of beach ridges, while the inner delta plain is a vast network of creeks and mangrove swamps. The delta has been a site of human settlement for thousands of years, but in recent decades, the landscape and its people have been profoundly affected by the activities associated with oil extraction. In this quiet corner, the slow, natural processes of the delta now compete with the faster pace of industrial change. Let the thought soften at the edges and fade. An estuary is a coastal body of water, where fresh water from a river mixes with salt water from the ocean. Some deltas form within estuaries. In these cases, the delta is often confined by the shape of the estuary's valley. The sediment from the river gradually fills the estuary, starting from the inland end and slowly building its way towards the sea. These estuarine deltas are often protected from strong ocean waves, allowing for the growth of extensive tidal flats and salt marshes. The Hudson River in New York and the Thames in England are examples of rivers that have built deltas within their estuaries. The river's end is softened and sheltered, a quiet infilling of a sunken valley. Rest in the steady comfort of this moment. The term Gilbert Delta is used to describe a specific type of delta formed by coarse sediment deposited in a lake. These deltas are characterized by a steep, sloping front. They were first described by the geologist Grove Carl Gilbert, who studied the ancient shorelines of Lake Bonneville, a prehistoric lake in what is now Utah. Unlike the gently sloping deltas found in most marine settings, Gilbert deltas have a distinct three-part structure with flat top-set beds, steeply dipping foreset beds, and flat bottom-set beds. They are a reminder that the delta building process can create different forms depending on the energy of the water and the type of sediment involved. Set the idea down and feel the weight release. The Sundarbans, located in the lower part of the Ganges-Brahmaputra Delta, is the largest single block of mangrove forest in the world. This UNESCO World Heritage Site is a breathtakingly complex network of tidal waterways, mudflats, and small forested islands. It is one of the last remaining strongholds for the Bengal tiger, which has adapted to living in this semi-aquatic environment. The name Sundarbans means beautiful forest in the Bengali language. The entire landscape pulses with the rhythm of the tides, with large areas of the forest being submerged twice a day. The forest is a powerful natural barrier, protecting the inland areas from cyclones and storm surges. With unhurried steps, this living wall of trees holds the line between land and sea. Let your shoulders drop and the jaw unclench. Delta restoration is a growing field of science and engineering. In many parts of the world, deltas are threatened by subsidence, erosion, and sea level rise. Restoration projects aim to reverse some of this damage. One common technique is a river diversion. This involves creating an artificial opening in a river's levee to allow some of its water and sediment to flow into a nearby wetland or bay. This mimics the natural process of a crevasse splay, delivering fresh sediment and nutrients to sinking areas and helping to rebuild the land. These are often small-scale, patient efforts to reintroduce the river's natural land-building power back into the landscape. Feel the calm gather around you again. The Ebro Delta in Spain is one of the largest wetland areas in the western Mediterranean. It protrudes far out into the sea, with long, sandy spits and shallow coastal lagoons. The delta is a patchwork of natural habitats and human-made landscapes, with vast areas devoted to rice cultivation. It is also an incredibly important site for birds, with hundreds of species using the delta as a breeding ground or a stopover point during migration. The shape of the delta has changed significantly over the centuries, responding to changes in the river's flow and human interventions, like the building of dams. Elsewhere in this picture, the land ebbs and flows, a quiet testament to its own fragility. Settle back into the soft pace of night. The land of a delta is not static. It is in constant slow motion. The process of avulsion, or channel switching, means that the focus of land building is always moving. While one area is actively growing, other older areas are sinking and being reworked by the sea. This means the map of a delta is never final. Over hundreds or thousands of years, the river paints a new landscape, abandoning old campuses and starting afresh on new ones. This dynamic nature is part of what makes deltas so resilient. The ability to shift and rebuild allows the system to adapt to changing conditions, a slow dance of creation that covers a vast stage. Allow the mind to idle in gentle space. Many deltas have a network of interdistributary bays. These are shallow bodies of water located between the main river channels or lobes. These bays are often quiet, low-energy environments where fine-grained sediments, like clay, can settle out of suspension. They are rich in organic matter and are often bordered by marshes. Over time, these bays can be filled in with sediment from floods or crevasse splays, eventually turning into new marshland. They are a key part of the delta's landscape, the quiet, watery spaces between the active arteries of the river, waiting patiently to be turned into solid ground. Let the body be held by what supports you. The Indus River Delta, shared by Pakistan and India, has a complex history. It once formed one of the largest arid climate deltas in the world. However, extensive damming and water diversion for irrigation upstream have drastically reduced the flow of fresh water and sediment reaching the sea. This has caused severe environmental problems, including the retreat of the delta's shoreline, the destruction of mangrove forests, and widespread saltwater intrusion into the groundwater. The delta, which once supported a thriving ecosystem and rich fisheries, is now a shadow of its former self. It is a stark reminder of the delicate balance that sustains these landscapes and how easily it can be lost. Allow the day to fall away now. The concept of a delta cycle is crucial to understanding how these landforms persist. A delta is not just a single static feature, but an assembly of parts in different stages of life. While a new lobe is prograding or building out, an old abandoned lobe may be transgressing or retreating. The delta as a whole remains stable because these processes are in balance. Sediment lost in one place is compensated by sediment gained in another. This continuous recycling and redistribution of land and energy is the engine of the delta's long-term survival. Through a soft lens, the delta appears not as a fixed object, but as a living system in slow, constant negotiation with its environment. Rest in the quiet that follows. The Atchafalaya River is a major distributary of the Mississippi River. For the past several decades, it has been capturing more and more of the Mississippi's flow. If left to its own devices, the Mississippi would likely have undergone a major avulsion by now, abandoning its current path past New Orleans and switching its full flow to the shorter, steeper route of the Atchafalaya. To prevent this, the U.S. Army Corps of Engineers built a massive control structure in the 1960s. This complex of dams and locks carefully regulates the flow, allowing only 30% of the Mississippi's water to go down the Atchafalaya. It is a monumental effort to hold a river in its course and prevent the delta from changing its shape. Let your breathing find a slower pace. The Yellow River, or Huanghe, in China is famous for its enormous sediment load. It gets its name from the color of the fine, wind-blown silt called loess that it carries from the plains of northern China. For centuries, the river has been known as China's sorrow because of its devastating floods and dramatic course changes. The river deposits so much sediment that it rapidly builds up its bed, causing the channel to rise above the surrounding floodplain. This makes it prone to breaking its levees and carving a new path. Its delta is one of the most dynamic in the world, having shifted its mouth hundreds of kilometers up and down the coast multiple times in recorded history. Feel the simple ease of being here. The shape and processes of a delta can be studied using physical models. In laboratories, scientists build small-scale replicas of deltas in large tanks or flumes. They can control the flow of water, the input of sediment, and the energy of waves, allowing them to watch a miniature delta evolve over a few hours or days. These experiments help researchers understand the fundamental physics of how deltas form and respond to change. By speeding up time and scaling down the landscape, they can witness the quiet, long-term processes of avulsion, lobe formation, and erosion in a way that is impossible in the real world. In the gentle background, these models reveal the simple rules that govern these complex systems. Hold only the calm and let the rest drift. Tidal flats, also known as mud flats, are a common feature in tide-influenced deltas. These are large, flat areas of muddy sediment that are exposed at low tide and submerged at high tide. They may seem barren, but they are teeming with life. They are rich in invertebrates like worms, clams, and snails, which live buried in the soft mud. These creatures provide a crucial food source for shorebirds and fish that come to forage on the flats when the tide is right. Tidal flats are the breathing spaces of the delta, a quiet zone that is given to the air and then returned to the water twice each day. The land is quiet, and so is the mind. The Danube Delta, which flows into the Black Sea, is the second largest and best preserved delta in Europe. It is a paradise for wildlife and a UNESCO World Heritage Site. The delta is a maze of reeds, marshes, lakes, and channels, hosting over 300 species of birds and 45 species of freshwater fish. The delta is still relatively natural, although it has faced threats from canal construction and pollution in the past. Today, significant conservation efforts are in place to protect its unique habitats. It remains a place where the slow, natural processes of delta building continue, largely undisturbed, creating a landscape of exceptional tranquility and biodiversity. The water flows onward without ever rushing. Storms can have a major impact on deltas. The powerful waves and high water levels of a hurricane or cyclone, known as storm surge, can cause widespread erosion and flooding. These events can reshape a delta's coastline in a matter of hours, washing away barrier islands and scouring new channels. However, storms can also have a constructive role. The storm surge can carry large amounts of sand and mud from offshore and deposit it inland, nourishing marshes that are sinking due to subsidence. So, while they are destructive events, storms are also part of the natural cycle of change and renewal in many deltaic systems, a sudden and powerful rearrangement of the land. Let that idea rest for a moment before we move on. Subaqueous deltas are parts of the delta that are entirely underwater. While we often think of deltas as visible land, a significant portion of the deposition and structure exists below the water's surface. As a river discharges its sediment, much of it settles on the continental shelf, building a submarine platform that can extend for many kilometers from the shoreline. This submerged delta is the foundation upon which the visible or subaerial delta is built. It represents the vast, unseen portion of the land-building process, a slow accumulation happening in the quiet depths, far from the light of the sun. Nothing urgent here, only a slow and steady pattern. The Colorado River in the United States once formed a large and ecologically rich delta where it met the Gulf of California and Mexico. However, over the past century, so much of the river's water has been diverted for agriculture and cities that it now rarely reaches the sea. The delta has been almost completely desiccated, its vast wetlands and forests turning into salt flats. In recent years, there have been experimental releases of water from the dams called pulse flows in an attempt to bring some life back to the delta. These efforts have shown that even a small amount of water can begin to revive the native vegetation, a hopeful sign that a small part of this great delta might one day be restored. You can breathe a little deeper and allow the thought to drift. The stratification of sediment is a key feature in deltas. As river water, which is fresh and often warmer, flows into the colder, saltier ocean, it doesn't always mix immediately. The less dense fresh water tends to spread out as a layer on top of the seawater. This density difference affects how sediment is deposited. Coarser particles may fall through the interface, while the finest clays can remain suspended in the surface layer and be carried far out to sea. This layering of water creates a more complex and subtle pattern of deposition than would occur if the waters mixed instantly. With simple patience, the water sorts itself, and in doing so, it sorts the earth it carries. Hold the shape of that thought lightly and return to ease. Barrier islands are long, narrow islands of sand that run parallel to the coast. They are a common feature of wave-influenced deltas. They form from sand that is reworked by waves and longshore currents, and they act as a natural barrier, protecting the mainland and the quiet lagoons and marshes behind them from the full force of ocean storms. The Chandeleur Islands, which protect the eastern part of the Mississippi Delta, are a prime example. These islands are not static. They are constantly migrating and changing shape in response to storms and rising sea levels. They are the delta's first and most fragile line of defense. Let the body grow heavier as the mind stays simple. The Fly River in Papua New Guinea has one of the largest sediment loads of any river in the world, relative to the size of its drainage basin. The island of New Guinea is tectonically active, with high mountains that are eroding rapidly. This produces a huge amount of sediment that the river transports to the Gulf of Papua. The river forms a massive, tide-dominated delta within a large estuary. The delta is a sprawling complex of mangrove-fringed islands, mudflats, and channels. It is a remote and largely pristine system, a powerful example of a delta in a high-sediment, high-energy tropical environment, building land at an astonishing rate. Let that settle like dust on a quiet floor. The study of deltas is important for understanding ancient rock formations. Many of the world's oil and gas reserves are found in ancient deltaic sandstones. By studying modern deltas, geologists can better understand the processes that created these rock bodies billions of years ago. They can learn to recognize the layered patterns of channels, bars, and shales that indicate a deltaic environment. This allows them to predict where reservoirs of oil and gas might be located. The quiet processes happening today in places like the Mississippi Delta are a key to unlocking the Earth's deep history and resources. Return to the easy rhythm of your breath. The Mackenzie River in northern Canada forms a vast delta where it flows into the Beaufort Sea in the Arctic. This delta is a labyrinth of lakes, channels, and low-lying wooded islands. It is the second largest delta in the Arctic, after the Lena Delta in Siberia. The delta is home to a rich ecosystem adapted to the short summer and long frozen winter. It is also a traditional territory for the Gwich'in and Inuvialuit peoples, who have lived in harmony with its cycles for generations. Like other Arctic deltas, it is experiencing rapid change due to a warming climate, with melting permafrost causing the land to sink and the landscape to alter in unpredictable ways. Let the thought soften at the edges and fade. Biogenic structures, or structures made by living things, can play a significant role in deltas. Mangrove roots, for example, trap sediment and build land. Oyster reefs can form large, hard structures that alter water flow and protect shorelines from erosion. Even the burrowing activity of crabs and worms in tidal flats can change the properties of the sediment, a process called bioturbation. These may seem like small actions, but multiplied over vast areas and long periods, they can have a significant effect on the overall shape and evolution of the delta. In these quiet landscapes, life is not just a passenger, it is an active participant in shaping the earth. Rest in the steady comfort of this moment. Deltas are natural filters. As river water flows through the vast network of wetlands, marshes, and channels, the vegetation and the slow-moving water work together to clean it. The plants take up excess nutrients like nitrogen and phosphorus, which can cause problems in coastal waters. The slow flow allows sediments and the pollutants attached to them to settle out. This filtering capacity makes deltas incredibly valuable ecosystems, protecting the quality of the coastal ocean. They are the kidneys of the continent, a quiet, sprawling system of purification that works day and night, powered only by the gentle flow of water. Set the idea down and feel the weight release. The Orinoco Delta in Venezuela is a vast and largely undeveloped wilderness. It is a classic fan-shaped delta, but its interior is a dense swamp forest, crisscrossed by a network of distributaries. The Warao people, which means boat people, have lived in the delta for centuries. They build their homes on stilts along the riverbanks and travel by canoe, their lives intricately adapted to the watery environment. The delta's landscape is constantly changing, with channels shifting and new islands forming. It is a place that remains largely governed by the natural rhythms of the river, a quiet testament to a way of life that flows with the water rather than against it. Let your shoulders drop and the jaw unclench. The growth of a delta can be incredibly fast in geological terms. Some lobes of the Mississippi Delta, for example, have advanced at rates of over 100 meters per year. The Yellow River Delta in China has built new land even faster at times. This rapid growth is a testament to the immense amount of sediment that some rivers can carry. While most geological processes are imperceptibly slow, a delta is a place where new land can be seen to form within a human lifetime. It is a rare window into the planet's creative power, a process of construction that you can almost watch in real time, if you have enough patience. Feel the calm gather around you again. Many deltas around the world are becoming more vulnerable to storm surges. The sinking of the land due to subsidence, combined with the loss of protective wetlands and barrier islands, means that there is less of a natural buffer to absorb the energy of a storm. A storm surge that might have once dissipated harmlessly in a wide marsh can now travel much farther inland, causing more extensive flooding and damage. The very features that once made deltas resilient are being lost, leaving the land and the people on it more exposed to the power of the sea. Settle back into the soft pace of night. The Po Delta in Italy is another delta landscape that has been heavily shaped by human activity for centuries. Extensive systems of dikes, canals, and pumps have been built to reclaim land for agriculture and to control flooding. This has created a complex mosaic of cultivated fields, lagoons, and remnant wetlands. The delta is a clear example of a coevolutionary landscape where natural processes and human engineering have become deeply intertwined. The land is no longer purely natural, nor is it purely artificial. It is a hybrid, a testament to humanity's long and complicated relationship with these fertile but challenging environments. Allow the mind to idle in gentle space. The sediment on a delta has a memory. The minerals in the sand and silt can be traced back to the specific rock types in the river's drainage basin. By analyzing the geochemistry of the sediment, scientists can determine where it came from. For a large river like the Mississippi, the sediment is a mixture from many different sources, a blend of the Appalachian Mountains, the Great Plains, and the Rocky Mountains. The delta is therefore a physical summary of the entire continent, a collection of tiny pieces from every corner of the watershed, all brought together to one place of rest at the river's end. Let the body be held by what supports you. The concept of base level is important for understanding deltas. Base level is the lowest point to which a river can erode its channel. For most rivers that flow into the sea, the ultimate base level is sea level. A delta forms because the river reaches its base level and loses its energy. Any change in sea level will change the base level, which in turn affects the delta. If sea level falls, the river can cut down and erode, and the delta will build outwards. If sea level rises, the river's mouth is flooded and the delta may drown or retreat. The entire landform is tethered to this invisible line. Allow the day to fall away now. Tidal bores are a phenomenon that can occur in some tide-dominated deltas and estuaries. This is a true wave, or a series of waves, that travels up the river against the current. It is caused by the incoming tide being concentrated in a narrow, shallow channel. The front of the rising tide becomes a steep, breaking wave. The Amazon River has a famous tidal bore, known as the Por Roca, which can travel hundreds of kilometers inland. These events dramatically, though temporarily, reverse the flow of the river and can cause rapid changes along the riverbanks, a powerful reminder of the ocean's influence far from the coast. Rest in the quiet that follows. The future of many of the world's deltas is uncertain. The combined pressures of sea level rise, land subsidence, and reduced sediment supply from dammed rivers create a serious challenge. Many of these regions are home to tens of millions of people and are critical for global food production. Scientists and engineers are working to find sustainable solutions, such as restoring wetlands, diverting sediment to rebuild land, and adapting communities to a more dynamic environment. This requires a new way of thinking, one that seeks to work with the natural processes of the delta rather than trying to control them completely. Let your breathing find a slower pace. The Godavari Delta in India is an example of a delta that has been built in a series of distinct lobes over time. Studies of the sediment layers show that the river has switched its course several times over the past few thousand years, building a new lobe in a different location with each switch. The older, abandoned lobes have been reworked by waves and have developed the characteristic curved shorelines of a wave-dominated system. The current, active lobe is more river-dominated, pushing out into the Bay of Bengal. The delta is therefore a composite of different shapes and ages, a physical record of its own restless history. Feel the simple ease of being here. Flocculation is a process that helps fine clay particles settle out of the water in a delta. Clay particles are very small and can stay suspended in fresh water for a long time. However, when fresh water mixes with salt water, the electrical charges on the surface of the clay particles are neutralized. This allows the particles to clump together, or flocculate, into larger, heavier aggregates. These larger clumps then settle out of the water much more quickly. This process is a key reason why deltas are so efficient at trapping fine sediment, a subtle chemical reaction that helps to build the soft, muddy lands of the lower delta. Hold only the calm and let the rest drift. Not all distributary channels in a delta are active at the same time. Typically, one or two main channels will carry the majority of the river's water and sediment. The other, older channels may receive only a small amount of flow, or may only be active during large floods. Over time, these minor channels tend to silt up and become abandoned, overgrown with vegetation. They remain visible in the landscape as long, linear depressions or as lines of different vegetation, tracing the ghost of a path the river once took. These abandoned channels are quiet memories in the land, showing where the heart of the delta used to be. The land is quiet, and so is the mind. The Copper River Delta in Alaska is a dynamic landscape shaped by both rivers and glaciers. The river carries a huge amount of sediment from the rapidly eroding Chugach and Wrangell Mountains, which are covered in glaciers. The delta is also in a tectonically active area. During the Great Alaska Earthquake of 1964, parts of the delta were instantly uplifted by as much as 3 meters. This single event created vast new areas of land overnight. The Copper River Delta is a place where slow, gradual processes are punctuated by sudden, dramatic changes. a landscape forged by the combined power of water, ice, and the Earth's deep movements. The water flows onward without ever rushing. Even in the calmest conditions, a delta is a place of subtle sound. There is the gentle murmur of water flowing in the channels, the rustle of wind through the reeds of a marsh, and the distant call of water birds. At the coast, there is the soft, repetitive wash of small waves on a muddy shore. In a mangrove forest, there is the quiet splash of a fish or the clicking sound of crabs moving through the roots. These are the quiet sounds of a landscape that is alive and in motion. As you rest, you can imagine this gentle soundscape, a soft and peaceful symphony of water, wind, and life. Let that idea rest for a moment before we move on. The size of a delta is not always proportional to the size of the river. The Congo River in Africa, for example, is the second largest river in the world by volume of water, but it has almost no delta. This is because it flows through a deep submarine canyon that extends right up to the coast. The river's sediment is funneled directly into the deep ocean through this canyon, preventing it from being deposited at the coast to build a delta. This shows that the shape of the offshore landscape, the bathymetry, is just as important as the river's power in determining whether a delta will form. Nothing urgent here, only a slow and steady pattern. The process of a delta building new land is fundamentally about energy loss. A river in its upper reaches has a lot of potential energy due to its elevation. As it flows downstream, this energy is converted into the kinetic energy of motion, which allows the water to carry sediment. When the river reaches the flat coastal plain and the standing water of the sea, this energy is dissipated. The flow slows, the turbulence dies down, and the water no longer has the power to do work. The sediment is the physical result of this energy loss, the material burden that the river can no longer carry. It is a process of surrender, a quiet giving up of a long journey's load. You can breathe a little deeper and allow the thought to drift. Deltas provide a gentle gradient of salinity, from freshwater inland to full salt water at the coast. This gradient creates a series of distinct ecological zones, each with its own community of plants and animals that are adapted to a specific range of salt tolerance. Freshwater marshes give way to brackish marshes, which in turn transition into salt marshes or mangrove forests. This zonation is one of the reasons deltas are so biodiverse. They offer a wide spectrum of habitats in a relatively small area. This quiet and gradual change in the water's character is mirrored by a gradual change in the life it supports. Hold the shape of that thought lightly and return to ease. We often think of river deltas, but deltas can also form in lakes. These lacustrine deltas are often smaller than their marine counterparts, but they form by the same processes. A river flowing into a lake slows down and deposits its sediment, building a delta outwards from the shore. The shape of these deltas is often influenced by the shape of the lake basin. Lake deltas are important habitats for fish and wildlife, and they often become areas of lush vegetation. A drive along the shore of any large lake will often reveal numerous small deltas, each one a miniature example of this universal process of land creation. Let the body grow heavier as the mind stays simple. The study of deltas requires a wide range of scientific tools. Geologists take core samples to read the history in the sediment layers. Hydrologists measure the flow of water and sediment in the channels. Biologists study the plants and animals that live in the various habitats. And remote sensing specialists use satellite imagery to map the delta's shape and to track how it changes over time. Putting all this information together gives a holistic picture of the delta as a complex, interconnected system. It is a science that requires patience and a gentle, observant eye, much like the landscape it seeks to understand. Let that settle like dust on a quiet floor. Ultimately, a delta is a place of transition. It is not quite land and not quite sea. It is not fully fresh water, nor is it fully salt. It is a boundary zone where opposites meet and create something new. The solid earth of the continent dissolves into the fluid motion of the ocean. The river's long, singular journey fragments into 1,000 smaller paths. It is a landscape of soft edges, where every boundary is blurred and always in motion. This gentle ambiguity, this refusal to be one thing or the other, is perhaps the most calming quality of a delta. It is a place of endless becoming, a quiet, shifting middle ground between two different worlds. Return to the easy rhythm of your breath. And so, our gentle journey comes to a close. We have drifted along the slow currents that build new land, particle by particle. We've seen how the patient work of water and earth creates these quiet, fertile landscapes at the edge of the sea. There is a deep restfulness in the image of a delta. It is a place of letting go, where a river finally releases the sediment it has carried for so long. It is a place of slow, constructive growth, a reminder that beautiful and complex things can be built without hurry in a rhythm of quiet accumulation. As you continue to drift deeper into sleep, perhaps you can carry that feeling with you. The feeling of gentle transition, of soft edges, and of a peace that comes from finding a place of rest. Sleep well. Good night.